In this example, we're going to be calculating average rate of change, or estimating it. The graph below shows the river level, L, in feet at a certain location as a function of time t in days, following the start of a large rainstorm that occurred upstream. We're going to use the graph to estimate the average rate of change of the river level over each of the following intervals. So the first interval is from time t equal 1 to time t equal 5. So we want to know what is that average rate of change between the first day and the fifth day. Let's begin by marking those points on the graph here. So at time t equal 1, we're talking that point right there, and the output at time t equal 1 for L is about 15. So we have 15 feet is the river level at day 1. And then at time t equal 5, if we look at that graph, the L, the function value there is 30. So now to calculate the average rate of change, we're going to take L of 5 minus L of 1 divided by 5 minus 1. So here we said L of 5 is about 30 minus L of 1, which is about 15, divided by 5 minus 1, which is 4. So we have 15 divided by 4, which is 3.75 feet per day. In part B, we want to find the average rate of change of the river level from time t equal 4 to time t equal 7 days. So we can plot those points at time t equal 4. There's our function, which is about 33 feet. And then at time t equals 7, plot that point, and we could say that that was about 18. So now calculating the average rate of change, we're taking L of 7 minus L of 4 and dividing that by 7 minus 4. So here L of 7 we said was approximately 18, and making an estimate based on the graph. And then L of 4 we said was about 33, all divided by 3, which is a negative 15 divided by 3, which is a negative 5 feet per day. So in this problem, we're going to suppose that Fast Trends determines that the revenue in dollars from the sale of X smartphone holders is given by R of X is equal to a negative 0.001 X squared plus 150 X. We want to find R of 305. So what we're trying to find here is what is the revenue in dollars from the sale of 305 smartphone holders. So plugging 305 in for X, it's going to look like a negative 0.001 times 305 squared plus 150 times 305. And then we can plug that in our calculator to simplify, and when we do, we get 45,657 if we round to the nearest dollar there. So that is the revenue from the sale of 305 smartphone holders. All right, part B, find R of 300. So now we're going to plug 300 in for X into our function. So we have a negative 0.001 times 300 squared plus 150 times 300. And then we can plug that in our calculator to simplify, and we get $44,910. So that's the revenue from the sale of 300 smartphone holders. All right, so now we're asked to find the average rate of change here, because we're taking the difference in the function values divided by the difference in the input values, and so that'll give us the average rate of change between 300 and 305. We already know what R of 305 is, so we take that, 45,657, and we're going to subtract that from that the revenue of 300, which we found to be 44,910, and then we're going to divide that by the change in the input values. So 305 minus 300 gives us 5. So that's going to look like 747 divided by 5, which is 149.4. So now what rate of change does this represent? Well, this represents the average revenue from sales of between 300 and 305 units is $149.40 per unit.